Okay, we're on page 91, and we're looking for sample space and a method of listing it. So, a student is taking a 93-point test. What is the sample space? And they want us to list it in roster notation. So theoretically, you can have none, and then 1, 2, 3, and you could use your ellipsis to go up to 93. So there would be 94 items, 0 being the possibility of having none. All right, in example 2, this is given an interval notation, but what is the sample space? So writing it in roster notation, it would be 2, 3, 4. You could you set up a pattern, your ellipsis again, or you could write them all out, there's so few. And that would be your sample space listed in roster notation. In number 3, we're looking for how many elements are there in the sample space of rolling a die. Well, this one's easy. 1, 2, 3, 4, 5, 6, there are 6 sides. All right, number 4. Now in number 4, there's a couple of ways to do this. We have clocks that are sold in blue or red with either digital or standard displays. So what would be the sample space of this? So a way to do it is make a little tree here. One is blue, one is red, and then of the blue we have digital and standard. Of the red we have digital and standard. And then you follow through. So here we have a BD, and then the next one is BS. That sounds like something here. Then we have an RD, and we have an RS. And there we've listed it. For number 5, what is the sample space for choosing a day in February? And you want to ride a bike, and the year being a leap year. Well, in roster notation, there is no 0 here, so it'll be 1, 2, 3, and you can use your ellipsis, and in a leap year there's 29 days. So that would be the roster notation for that. On page 92, the days of the week is chosen for a potluck. We're still doing sample space. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. We flip 3 fair coins, find the sample space for at least 2 heads. Now, we did something like this in the textbook, where again we developed this tree chart, where these are sort of like the branches of a tree, and we are flipping fair coins, but we're going to do it 3 times. So we have 3 fair coins, so this will be 1, 2, third toss of the possibilities. So as you go up along this line, you're going to get H, H, H. Along this line, H, T, H. That would be this line. Now you go this line, H, T, H. So we end up with this. Now we're wondering, find the sample space for at least 2 heads. Well, we can outline them. There's at least 2 heads. There's at least 2 heads. 2 heads. And then 2 heads. So we have these 4 would be our sample space for at least 2 heads. And again, I think this is an excellent way to, when you have something like this, to get results. Now we're going to see this again, and we'll do it one more time. In number 3, we're going to pick a random month of a year. So we just list all the months. January, February, March, April, May, June, July, August, September, October, November, December. Okay, number 4. All right, you want to read what they're saying. The guy's going to have a umbrella here for the patio. There's a 7-foot version, a 13-foot version, and they're available in red, white, and yellow. So, what is the probability that he's going to buy a 13-foot white umbrella? So for this one, we have a white and a 13-foot. So we have, there's 2 types and there's 3 colors, so there's a total of 6 in the sample space, and he's picking out one of those. So 1 out of 6. Now that he buys a 7-foot umbrella. Well, again, our sample space is still 6, but he has 3 that are 7 feet in the different colors. So this will reduce to 1/2. He buys a red color umbrella. Well, he would have, out of the 6 possible, he has a 7-foot and a 13-foot, so he has 2 out of the 6, which reduces to 1 out of 3. All right, let's go on to number 5. Well, for number 5, it's going to be similar to what we had up above. Here we want 3 questions. They're either going to be correct or wrong, and the student is just going to shoot for them randomly. And then we're going to answer these questions, but we need to do our sample space first. So let me give you a moment to do this. Set it up in this fashion. Correct, wrong. So this would be correct, wrong. Correct, wrong. And then you're going to do 2 more out of each one. Getting a little bit out of space here. So I was looking this over, and the other one that I did, I made a little error right in there. Hopefully I pointed that out to you. But again, we have true, false, or correct, wrong. And this student is going to just randomly try these 3 answers. So what are all the possibilities? Well, there are 8 possibilities. And here there were 2, and then it gave us 4. And then here are the 8. So we just go along this line. C, C, C gives us this. Then C, C, W gives us this one. And that's, I believe, where I was off a little bit. But notice that this one and this one are the same, except for the order. So, what is the sample space of the experiment? Well, the sample space would be these 8 trios here. Write the event. The student gets 0 correct answers. So, to get 0 correct answers would be this last one here, where there are no correct answers. They're all wrong. So the probability of that would be 1 out of 8. And write the event. The student gets only the last question wrong. Well, looking through here, where this is the last question, they would get it wrong there. Only the last question. So that implies you have the first 2 questions correct. And the probability of that one is 1 out of 8. You lucked out either way. So for page 93 now, we're wondering whether these would be a disjoint set, like so, or not. So being a taxi driver and not have a driver's license. Now, if you are a taxi driver, you must have a driver's license. So these would be a disjoint set. So this is yes. And then being a doctor and being a male. Well, you could be a doctor and you could be a male. So this is no. This is not a disjoint set. Being trustworthy and being employed. Well, you'd have a circle and you could be both. So this is a no. Being a football player and being over 25. The same, you could be both. So this is not disjoint. Now, being a nurse and being a baby, they are a disjoint set. So this is yes. Okay, we'll wrap this up with 3 pages.